Question number 3. It says the diagram shows an isosceles triangle and a square on a straight line. We've got to calculate angle A. Well, there's the isosceles triangle, there's the square, and there's a little angle between them that's angle A. The trick with this one is to realise that it's saying on a straight line, because we already know that angles on a straight line must total 180 degrees. And the straight line that they're talking about is along the bottom here. Now if we draw in a semicircle round here, we've now got 3 angles. So we've got angle A in the middle there, we've got a square in the angle in the corner of the square is there, and we've got the angle in the isosceles triangle which is there. So we've got 3 angles, and these 3 angles must total 180 degrees. So if we can work out the pink angle and the orange angle, all we will need to do is subtract those from 180 degrees and we'll be left with angle A. So the question is, what do we know? Well, the orange angle is easy. This is the corner of a square, and the corner of a square, as we know, is 90 degrees because it's a right angle, so we can fill that one in. That's got to be 90 degrees. The angle in the isosceles triangle is going to be the same as this angle over here, because the whole point of an isosceles triangle is that there are 2 sides the same, which is shown by this mark and this mark. So these 2 sides are the same, and because it would be symmetrical down the middle, that means these 2 angles are also the same. So that's what we've got to work out now. So in the triangle, if we start from the fact that we know that there are 180 degrees in a triangle, if we subtract this 34 degrees, we will be left what these 2 angles must make together. So 180 subtract 34. Now we could do a column method, but this is a calculator paper, so let's use a calculator. We might as well take advantage of it. 180 subtract 34 is 146 degrees. So these 2 pink angles together, these 2 pink blobs, must make 146 degrees. But they are the equal angles. So what we've got to do is split the 146 in half. So we've now got to do, each angle is going to be 146 degrees divided by 2. We've got to split the 146 equally. So 146 divided by 2 is 73 degrees. So both of these pink angles must be 73 degrees each. However, we're now in a position to find angle A, but we don't really need to use this 73 because although it's sitting on the same straight line, it isn't part of the semicircle. And remember, it's the angles on the straight line must kind of complete the semicircle for them to equal 180 degrees. If you start adding on this 73, that's going to be an extra angle on top of the semicircle. So now we're down to the semicircle, or angles on a straight line. So angles on a straight line equal 180 degrees, and all we need to do is take away the 73 and take away the 90, and we'll have the missing angle. Another way of doing it would be to add these 2 together and then subtract it from 180. So we could write it like that. We could subtract the sum of 73 and 90 together. Whichever way you do it, it will still work. So let's find out what 73 and 90 is. So 73 add 90 is 160 degrees. So we're actually subtracting 163 degrees from 180. Probably will be able to do that in your head, but let's just double check. 180 take away 163, and it is 17 degrees. So we found that angle A in there must be 17 degrees. And that's the answer we need to put in the answer spot. 17 degrees. There is a quick method that we could do to check this. We could say that, well, now we know all three of these angles that are sitting on this straight line. We know that they've got to equal 180. So let's check to see if they do. So we've got 73 plus 17 that we've just worked out for angle A, plus 90 that's in the corner of the square. Let's see what we get. So we've got 73 plus 17 plus 90, and indeed that does equal 180 degrees. So it all works out. 93 in the corner of the square, 73 in the isosceles triangle, and 17 for angle A.